All right, ladies and gentlemen, we're going to go ahead and start on Chapter 5, Computers in the Learning Environment. And we're going to kind of take a look at how computers work, the hardware and software aspects of them, and just see how this technology can assist us. So, how do computers work? Well, I was told by another instructor that taught me computer literacy years and years ago, said that computers were the dumbest machines on the planet. Well, they are simply machines that carry out your instructions. They can't think for themselves. All they can do is do what you tell them. And that's it. Now, they're very versatile. We can use them in a wide variety of situations, but they're not limited to predetermined tasks. We can program them to do other things. We just aren't limited to a single few tasks. We can do a wide variety of things with our computers. And pretty much what we have to do is to provide some input for the computer through the use of a keyboard, mouse, camera, whatever it is. And then the computer will process that information and then put forth output, either in the form of pictures that we can print or that we can see on our monitors. So we can get our output in a number of different ways. And if you have a degree of understanding about how computers work, then you can kind of help them to kind of help you work more efficiently or use them more efficiently. So let's take a look at the computing cycle. When we turn that computer on, the computing cycle begins with input. You and I have got to do some input, whether we're typing in letters or characters, or whether we're moving our mouse to click on icons to command the computer to do things. There's got to be some input. Then that input, those signals are processed by the computer's processor. It takes all of that input and basically changes it into a digital format that can be displayed and also stored. We can take our information, save it to a hard drive on our computer, or a thumb drive, a flash drive, or on a CD-ROM, or a DVD disc, and store it and keep it for a later time. And then finally, output, whether we can either see the data that we've input, or else get a hard copy of it from a printer. Now, your computer system is composed of some hardware. That's the physical equipment, the processor, the motherboard, the drives, hard drives, external drives, keyboard, mouse, monitor, all those things and more bundled up. Or else if you have a laptop, it's all self-contained. And then software. Those are digital programs that are loaded into the computer's memory or a hard drive to be executed whenever we want it to happen. Now, it takes both of these to make a computer work. If we have hardware and no software, all we got is just a bunch of metal, plastic junk. Software without hardware, all we have is some disks that might make good coasters, but that's about it. But when you use the two together, wonderful things happen. Now, let's look a little bit more about input. That your input is the data or programs entered into the machine by the user. Whenever we load software or we initialize software with our mouse, that's input. And let's say we're initializing Word, then we sit there and type our letter, or else we're in Outlook and we're doing some emails. Well, that's all input. That information was inputted by us. The central processing unit, or CPU, receives the input for processing and directs and executes necessary tasks. There's some things that have to happen for that data to be moved to where it needs to be, and also to be transformed from the input signals into digital format. That processor does that millions of times a second. These things are incredibly fast in how they do things. Then that information is sent to what is called random access memory, or called RAM. That might be used by the CPU to temporarily store data during processing. It can send it to the RAM sticks that are in the motherboard of the computer and store it there, or else pull everything into the RAM so that you can utilize the application very, very quickly, and then take that data once it's been changed and store it. We've got disks. One type is a hard drive. We can have CDs or jump drives or any other kind of storage device that is used to kind of store data more permanently. In the RAM memory, data is stored temporarily. Whenever you turn off your machine, the RAM memory gets erased. But yet, when it gets written to the hard drive, then it's saved permanently, or until we decide that we want to erase it. Then, of course, we have output devices that will receive the data when the processing is complete and either display it on a monitor or printer, so that we can get us a hard copy. Now, that computing cycle takes place as long as that power switch is turned on. Whenever we turn it off, then the process ends. And here's a good graphic of the computing cycle. You can see the mouse there. Here's where the input comes in. The CPU processes it, sends it to storage or to memory. Depends upon how we're the size of it, but yet it'll pull that software up into memory so we can do what we want with it. And then once we exit, it gets processed back to the storage and stored there permanently. And then, of course, we see the output there on our screen or on our printer. Now, hardware and software make the computing cycle possible. And so hardware, like we said, is all the physical components of a computer, and software are all the programs telling the computer how to perform those tasks. But we have to have both of them for that machine to work. Now, let's take a look at something called read-only memory, or ROM. These are program chips on the motherboard that provide temporary processing memory. This ROM memory stores the computer's basic input-output system, or BIOS, that tells the computer how to function and stores no other information permanently. Whenever you press the power button on that computer, there is a BIOS chip on that motherboard that tells that computer how to turn on. And it goes through all kinds of checks of the system and tells that computer what stages it needs to be, what things need to be turned on at what stages. And then once it's done, the BIOS shuts down. And then whenever you turn your computer off, and turn it on again, the BIOS reinitializes. So every time you turn your computer on, the BIOS is giving all the instructions to that computer on how to turn on and to check itself. The BIOS is stored in ROM when the machine is built, but can be upgraded. There are some, they call that flashing the BIOS. We can upgrade it. It's something that shouldn't be done by someone with not a lot of experience with computers, but it's a fairly simple task to go out there and download the new software and then load it and flash and upgrade that BIOS, because let's face it, new improvements are made in software all the time, and so we need to be able to do those upgrades when necessary. Now, let's take a look at one output device, and that's a graphical user interface, or GUI, and they call it sometimes a GUI display. Both Windows machines and Macintosh machines use a graphical user interface, or GUI. And this kind of interface uses icons or small graphics or pictures of software or of items to kind of symbolize them. And they can represent objects, programs, and data. And so instead of having a bunch of text right there that would tell us what was in those files or those applications, we see pictures. And let's face it, we're pretty much visual learners anyway, for the most part. So this works a whole lot better for people. And you execute the commands by just using the mouse to click on the icons. In a GUI operating system, you click on an icon and issue a command. So you just find the file or icon you're looking for, click on it using the mouse, and that command will be executed. Now, what kind of software programs are out there for us? Well, the first and most important type is, at least in my mind, is your operating system, or OS. It provides the interface for the user and enables the computers to run programs. This is pretty much the environment that your computer has for you to work in. There's all kinds of operating systems out there that you can utilize, and some of them are free that you can download. Some of them you have to buy, like Windows or the Macintosh operating systems. But that software kind of integrates your hardware, your software applications for you to get some things done. Then, of course, you have your applications programs, which tell the computer how to achieve a specific task. Are you doing a spreadsheet? Are you doing an email? Or are you surfing the web? Or are you doing and creating a database? You need application software that can get that done, or playing a game for that matter. Then we have utility programs which help maintain the machine and its operations. We have all kinds of little utility apps that are built into the software that will help to, clean it up, clean up the hard disk, delete files, combine files, connect hardware on there. There's just tons and tons of software that's built into the operating system, and also these application programs that can do a lot of different things. Or else you can download a bunch of utilities that are standalone utilities that will work for you to do a lot of different things. Now, let's talk a little bit about application software. We've got a number of software titles that kind of fall under the administrative category. These are applications that help teachers perform administrative tasks, and they have listed Word and PowerPoint. You and I can do letters, we can do tests on Word, handouts on Word, and then we can use PowerPoint to display our lessons visually. And also we can animate, put sound, put videos on these PowerPoint presentations to make them as complete as possible. But this kind of helps us with the daily administration and teaching that goes on in our courses. And then we have a whole bunch of academic applications that are programs that help you teach and your students to learn, like tutorials, electronic encyclopedias, a bunch of math games, English, reading programs. There are just literally millions of them out there for all kinds of grades, all kinds of educational levels. Application programs are sometimes bundled and sold with related software in an application suite. Used to be that you could go out there, let's take the Microsoft suite of software like Word, PowerPoint, Excel, and Access, the database program. You had to buy each one separately. But about 15 years ago, they began to bundle this software all together into one package, and also make all of that software work together as like one complete package. For example, if I'm working in Word, I can take an Excel spreadsheet and move it quite literally just like it is into a Word document, and it will be copied and pasted in there, and can be displayed. I can take some access table data and put it into Word, or I can take a Word document and pull it into PowerPoint seamlessly. And so that's a wonderful, wonderful attribute that this software has now that it didn't have before, because a lot of this software years ago was not compatible with each other. These bundled software packages combine several popular applications into one package or suite. Of course, like I said, they give you the Microsoft Office suite. This little program that presentation that I'm using is off of another suite of software. It's the Adobe Creative Suite software. And so very, very good suite of software. There's about 8 different software packages that come with it, and they're all basically used to do a lot of online learning. So it works real, real well. Integrated software are packages that are many versions of applications sold as a single software package, like iWork. Or else you can also get single versions of like the Microsoft suite and other software packages, but thing is, you're just limited in what you can do. Now, software has a specific system requirement like computer memory, processor speed, so check the computer specifications before buying. So you want to make sure that your computer is going to be able to handle the software that you're going to be using, and so just make sure that you have your specifications, and then whenever you go to purchase your software, if you look at the box that it comes in and look towards the back, and it will tell you and list what the recommended specifications are for a computer to run that software. But please, obviously, make sure whenever you buy your software to make sure that whether it's for the Mac or for the Windows-based system, that you don't want to have that kind of problem right up front because they are not compatible. And then if this is your typical desktop computer system, here's your case that has your motherboard, processor, and so forth, RAM all bundled in here. Then you have a DVD drive, CD-RW drive, a floppy disk drive. Now they are getting rarer and rarer all the time. Your mouse, keyboard, then your output, your monitor, speakers, printer. So those things do all kinds of stuff for you. Your input devices are user devices that send data or programs into the computer. Like we said, the mouse, keyboard, digital camera, scanner. Those are all input devices. And of course, the most common are your keyboard and mouse. But you can also have trackballs, joysticks, touchpads, microphones, like what I'm using right now to record this. I have a little boom mic right in front of me that does a really good job. But my voice is being transmitted and processed digitally by the CPU right now. Now, your output devices move processed data from the computer to you and me. Now, your monitors will display your data as a soft copy. They vary in size, and one thing to remember that if you see the size of the monitor listed, that size is measured diagonally across the monitor. It isn't straight across along the width. It's always measured diagonally. So be sure that you remember that. And they will vary in their clarity, just how sharp the picture will be. You have basically two types: cathode ray tube, which are the old types of monitors that work just like old-time televisions with the vacuum tubes, or a cathode ray tube that would show the image. But today we use liquid crystal display, or LCDs, or LED, light emitting diode monitors, which are thinner, lighter than your regular old cathode ray tube. And now, what about printers? They display data in a hard copy output. That means you get a sheet of paper and you will see your information printed on it. They can also vary a lot in resolution, about the quality of the print, the speed. You can have color versus black and white, and the features that it may have. Most common types we have today are the inkjet printers and laser printers. Inkjet printers kind of work like a paint sprayer, just a miniature version of a paint sprayer. They actually take very tiny droplets of ink and spray it on a sheet of paper. Laser printers use heat to take this toner powder and adhere it to the paper. That's why whenever you have a laser printer, whenever you feel the output, it's warm. It passed through a heater that basically baked that toner to that paper. Inkjet printers will print in both black and white, or what they call monochrome, or color. Now, let's kind of shift gears to the central processing unit, or CPU. They control all the machine processes. Everything that takes place in that computer is controlled by that CPU. What that processor can do is measured by the information that it can process at a certain speed. And we're talking billions of bytes a second, gigabits or megabits, millions of bytes. Now, the higher processing speed that we have on that processor, the faster work can get done. And so understand that the faster chip that you get in that computer, the more expensive that chip is going to be. And so just be aware that you pay for processing power. And your speed is measured in megahertz or millions of hertz or cycles. Hertz refers to the cycles of electricity, and so megahertz would be millions of cycles per second. Random access memory, or RAM, temporarily stores programs and user input, and that's referred to as memories. It's just a place for us to put that information to process it. And it's measured either in megabytes or gigabytes. Megabytes is millions of bytes. Gigabytes is billions with a capital B. Now, the greater the amount of RAM, the faster the computer can store and access data without needing to access drives. If a computer has to access the hard drive, that slows it down. We want enough memory to be able to pull all of our application into RAM memory so we can work with it and modify it and create stuff with it. And then once we save it and then store it on the processor, store it on the hard drive, we want to be able to do that. But we don't want that computer having to pull information from that hard drive, because that will slow down the process. And so we have to have a whole lot of memory on our computers to be able to do that. And normally most computers today will have like maybe 2 to 4 gigabytes of RAM memory in order to utilize all of the very complex application software we've got today. And also, especially those people who like to play games, those games just take tremendous amount of RAM. And so there's an example of a RAM chip, or a stick of RAM, that, like we call it. And so when you save it, you can save it to a floppy disk, or you're not seeing a whole lot of these anymore. But we used them at one time to temporarily and to store data and to keep it on file for us whenever we needed it, or to a hard drive. These things can hold billions of bytes of information, or else even to the trillions now. Your CD or DVD drive will take that data and then burn it to a disk so we can save it. These are great. They're cheap, and they hold a lot of information, especially the DVDs. Or we can put it on a flash drive, which is probably becoming the most popular form right now. In fact, chances are these may be replacing, certainly have replaced the floppy, and there's some talk of them even replacing DVDs and CDs because of the amount of information that can be stored on them is very steadily increasing, and their costs are going down quite a bit. So what about storage? Your CPU stores data temporarily in RAM or more permanently on a storage device like a hard drive. Your storage devices can be floppy disks like we've seen, hard disk, optical disk, or USB jump drives in the preceding picture. Now, when you hit the save command, that moves that data from RAM to that storage device that you tell it to go to. Now, here's a little table dealing with the relative sizes of stored data. When they talk about bytes, how many bytes in a hard drive or something like that? Well, a byte, the approximate value of a byte is like one alphanumeric character or like one keystroke on a keyboard. A kilobyte will be 1,000. A megabyte, 1,000,000. A gigabyte, 1,000,000,000. And then terabyte is trillions. And so you see the relative sizes of what that amount would be in text. It's incredible the amount of storage we have available to us today. Hard drives are usually fixed inside the computer, but you and I can buy portable hard drives that will travel with us and store data that we can just, they're called external hard drives. The hard drives that I've just mentioned are called internal hard drive. If it's inside the computer, it's internal, and we can have some that are only outside too. That's usually where we have programs and applications stored for us whenever we want to use them. They can offer large storage capacity, 10, 20 terabyte hard drives are very affordable for schools and for personal use. They provide fast access time for data retrieval. Doesn't take long for that hard drive to read that information and pull it up in the RAM for us to use. But since they are mechanical devices and they do wear out, they can crash or fail. So it is critical that you and I back up our data periodically. And there are utilities that will do that for us automatically or manually, whatever we decide. Now, floppy disks, they have a very small capacity for storage, but they are easy to carry. You put them in your shirt pocket or in your purse and go. They're kind of rugged, but they will only store a few files. Now, the ones that have the plastic outer shell are relatively durable, but the original floppies were very thin and very flimsy. And so you had to be very, very careful how you handle them, because you could bend them and crease them, and then once you did that, they were ruined. But they are rapidly becoming obsolete. In fact, for the last 5 years, I don't think we've ever bought any computers for our campus that had floppy drives. Now, as with any kind of removable media, they can carry viruses from computer to computer. So if a student has a floppy drive that has a virus on it, they go from computer to computer with that floppy. They can carry that virus from computer to computer and infect the whole network very, very quickly. Now, removable storage can be flash memory, like a flash drive, memory stick, or an external type of hard drive. You can get those for less than $100. That will be like 500 gigabytes or larger. They're very affordable. They normally connect to what is called a USB port, a universal serial bus port that have like a little rectangular socket that it fits in. The little flash drives will vary in capacity of 64 megabyte to 1.5 terabytes, or they're up to now about 5 to 10 terabytes for a hard drive. And so there's a wide variety of storage capacities depending upon the device that you use. They're good for transfer, backup, or archive storage of large or large amounts of files. We can store large files like videos on that kind of storage device, or use a hard drive or external hard drive to kind of copy our whole hard drive of our computer to in case it crashes. We can go back, put a brand new hard drive in, and then take that data from the external hard drive and basically reinitialize all of our computer files. It's like the hard drive never messed up at all. Now you got your optical media, your CDs and DVDs. Your CD will hold about up to 650 megabytes, and it's been a standard computer component for about the last 10 or 15 years. But then we've got the DVD, which can hold up to about 9 gigabytes. So we're going from 650 million to 9 billion. And it's really become the new standard optical medium. And it was originally used for video, but now we use it to store files of all types. Now, one thing you got to watch for is the nomenclature on the CD or DVD. If you see CDR, the R means that you can record that CD one time, and that's it. Or another way we describe it is that we can burn it, because literally a laser beam burns that CD or DVD media, and so we can use it one time. But we do have a new type of optical device that's called the CDRW, which means CD read write, which will allow us to re-record over that information, so we can use the disc more than once, which is good. Now, you may see this DVD plus minus RW. When DVDs were created, two companies came up with two different formats, a plus and a minus, and they are not compatible with each other. You have to be able to have a player that will play both of them, or else you'll see a player that will play a plus format and a player that will play a minus format. You'll hear a lot of students say, "Oh, doc or whoever, I took my CD and I brought it home and I put it in my computer and it wouldn't play." Well, chances are their format is wrong, or certainly if they burned or if you copied some music or a movie and you put it in your DVD player at home and it doesn't work, but you put it in your computer, it plays fine. Well, what you've got is a formatting problem. You either you copied it as a minus, and your player is a plus, and so not going to work. And of course, you have your DVDs that are read-writable too, and so you can use them more than once, or else one time. Now, let's talk a little bit about networking. Today, a bunch of computers have been connected together. Like you see right here, here's a bunch of computer workstations. This could be in classrooms or a lab or at a school. They're connected to a computer component called a switch. And that switch then sends all that information to a large computer called a server that connects to a web server that will connect to the World Wide Web. and then connect to any kind of website we want to go to. And that's pretty much what networks look like. But they are a collection of computers and peripherals that are connected together. And the network workstations are connected to a server via either cable or hardwire, as they'll call it, or either copper cable or fiber optic cable, or they will connect wirelessly by the way of radio waves. Your network may have a server, a more powerful computer configured to facilitate communications and sharing of resources. This computer has software that's made to store information and allow rapid access to that information for a number of computer systems. This isn't computer operating systems that you and I are going to put on our desktop machines. This operating system is specifically designed for this kind of computer, and you have to have it to get the most out of that software. And of course, we can connect either via wire or wirelessly. Now, we have some connections called local area networks, and these LANs, as they're called, can serve a local area such as a single school. You know, you've got all your rooms kind of all connected together. You have what are called wide area networks, or WANs, which can serve a wider area like a school district. And then you have these WANs will typically include multiple local area networks, and so you have your local area network at your school, and they will connect to the WAN and connect all of those LANs together. And so one of the things that we have to worry about whenever we're dealing with networks is the protocol. That protocol, which is how we share information from computer to computer, has to be the same across the network. Now, another thing we have to worry about is the bandwidth that can support the transfer of that information. The bandwidth will determine how much we can move from computer to computer. And so sometimes when a lot of people are on a network, the network slows down tremendously, and you're waiting and you're waiting for something to get done, and it doesn't. Well, chances are more people are using it and using up all the bandwidth, because the bandwidth is finite. We only have so much to utilize. And so if we have too much traffic, that can kind of clog things up. So bandwidth is a major point of emphasis for those that are designing networks in schools. And then we also need to have some kind of security. And it has to be implemented and continually monitored and upgraded, because there are people out there that are going to want to hack our networks and get to all the data that we want, or else plant some viruses on that network and let them wreak havoc on our computers and wide area networks and local area networks. Now, what's nice about networks is that you can share your resources, and you can share all kinds of resources and software, academic, administrative software. You know, one license can feed a whole lot of stations, and you can put data in personal, create personal folders for instructors to put all of their information in at one time, to put their data files, or else create folders for their work. You can share printers drives, scanners, and so forth. Most of our peripheral devices today are networkable. And so instead of having to buy one for everybody, you get one nice one that everybody can use and has access to. And also, we can share communications like email, a calendar, and of course, internet access. So why should you and I know about computers? Well, we need to know enough to be able to meet the ISTE or NETS-T requirements for certification. But we also need to be able to know and use that kind of technology appropriately and effectively. For those teachers that use computers for their students to kind of stay entertained, it's of no educational value to them. All they're doing is basically babysitting. But if we do have instructional software that we can use and make a part of the learning process, we can get something out of it. We also will need to be able to handle some minor computer problems. And let's face it, computers are machines. They do have problems. Some we can take care of. Some fixes are just as simple as turning the machine off and turning it back on, and it can get fixed. There are some situations, though, that are out of our level of expertise, and so when that happens, most schools and businesses will have someone that's trained to do that, or they call it their IT or information technology staff. And so we may have to call them to do some troubleshooting and repair and recovery. We ought to know how to use computers because we might need to help students use computers. Let's face it, today that's become rarer and rarer because most students have grown up with computers today, and to them the technology is no big deal. They've been using it for years. But there may be some, especially older adults, that may come through our courses that have not had that kind of experience. And of course, we need to recognize where we can't touch this issue, we need some professionals to take care of it. And we just need to know how to use both hardware and software to effectively support learning in our classrooms. So that will do it right there for Chapter 5. And so we will end it right here and then start working on Chapter 6.